Hello students, welcome to the CBSE Chemistry lecture series. Today we are going to discuss about organic chemistry, IUPAC nomenclature. Part 2. Here in this IUPAC nomenclature, so we will discuss the fundamentals first. Already in the last video, I will give the outline of that systematic method of giving a names to organic compounds in a systematic. That is what IUPAC nomenclature. International Union for Pure and Applied Chemistry is an organization. They are framing a set of rules and regulations. Based on that only we have to give the IUPAC names. So the last class I discussed about the PRS. PRS is nothing but R is a root word, or you can say parent name. S stands for suffix and P stands for prefix. So based on this we are going to discuss about few organic compounds. First we will take a hydrocarbons. When we classify the hydrocarbons, the compounds containing carbon and hydrogen only, it is further classified as what? Aliphatic and aromatic. Aliphatic, or you can say open chain compounds. Here it is a closed chain compounds. Closed chain compounds. Okay. So in this particular, yes, first we are going to discuss about what? Organic chemistry. In that one, IUPAC nomenclature. So the basic is what? P or S. P stands for prefix, R stands for root word or parent name, S stands for suffix, and this hydrocarbon, aliphatic or open chain compounds, aromatic. In aliphatic, we are having a compounds like alkenes and alkynes. So first we will take this type of compounds with examples and what is the rules and regulations for these compounds. Before discussing the IUPAC nomenclature, first we various representation of organic compounds. Various representations of organic compounds. Alkanes. Its general formula is CnH2n plus 2. What is that N represents? N represents number of carbon atoms. Say for example, if N is equal to 1, you substitute in this formula C1H2 into 1 plus 2. Then you have to say C1H4. If you write like this, then you have to say it's a molecular formula. This is one form of writing the organic compounds, molecular formula. The molecular formula will tell us about the number of atoms like carbon 1 and hydrogen 4. Same thing, if you write in this manner, we can say it's a structural formula. You have to say it's a structural formula. Structural formula. Okay. Suppose if you are writing like this CH4, then it is a condensed structural formula. And we have to give the IUPAC name for these compounds. What is the IUPAC name for these compounds? Everything is what depends upon number of carbons. If it is a one carbon atom, then you would say what? Meth. And here it belongs to alkane type, so the suffix is what? ANE is a suffix. So methane. This is an IUPAC name for this compound. Okay. Similarly, we can write another one compound belongs to this type of alkane series. So you will take a n is equal to 3. You substitute in this formula. Then you have to say it's a molecular formula. C3H 2n plus 2. So 2 into 3, say 6 plus 2, 8. C3H8. Then if you write like this, then you have to say it's a molecular formula. What is the structural formula for this compound? So you have to put a 3 carbon atoms. And based on this valency of the atoms, you have to fill up the hydrogen atoms. So 1, 2, 3. You should not put more than this one because the valency of carbon is only 4. So here you have to put only 2 hydrogen atoms. Here you have to put a 3 hydrogen atoms. You have to check 3 carbon atoms and 8 hydrogen atoms. Then you have to write a condensed structural formula. How can you write this condensed structural formula? C surrounded by 3 hydrogen atoms. So CH3 bond CH2 bond CH3. This is called condensed structural formula. Then you have to say what is the IUPAC for this compound. So 3 carbon atoms you have to say it's a prop. And it is an alkane, so you have the suffix ane, propane. And one more representation is known as bond line formula. Bond line formula. What is that bond line formula? We are no need to mention these atoms as carbon, as hydrogen, just by putting a line. So you have to think about 3 carbon atoms. You have to put a 3 lines, and you have to connecting all these things. And this is what bond line formula. And if you check, so here this is a carbon atoms. Assume that this is a carbon atoms. And this is also another carbon atom. This is also another carbon atoms. Based on the valency, you have to fill up the hydrogen atoms. 1, 2, 3 only we have to fill up. So these 3. Only here what? Already 2 bond is there. So you have to put 2 hydrogen atoms. Here 1, 2, 3. So without representing the atoms, just by line, that is called bond line formula. Okay. Now based on this, I will write the rules for IUPAC nomenclature. Rules for IUPAC nomenclature. I am going to give the general rules. First, you have to select the longest carbon chain as a parent name. So while naming the organic compound, you have to select the longest carbon chain. Or longest continuous carbon chain. You have to choose like this one, continuous carbon chain as a parent name, or you can say root word. Parent name, or you can say root word. That is the first rule. Second one, which side we have to give numbering? So you have to start numbering from the functional group side. Or lowest locant side. Lowest locant side. In that manner only how to give number to the organic compounds. Third one, if same alkyl substituents, or any other substituents, if it is a 2 times, then 2 times means use prefix as di. If it is a 3 times, tri, and so on. Suppose if it is a different alkyl groups, if different alkyl substituents, then arrange the substituents in alphabetical order. Arrange the substituents in alphabetical order. And the last one, that's what, fifth one, while writing the IUPAC nomenclature, if number and number, put comma. If number and alphabet, put hyphen. Just like this. And whole thing you have to write as a single word. So this is a way of writing the IUPAC nomenclature for all organic compounds. Let us take some examples and discuss. Yes, we'll take a few compounds like this one. So the first compound, you apply the rules first. Select the longest carbon chain is a parent name. So you have to number is at what? 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7. So any side you can give the numbering, but see the second one. Start numbering from the functional group side or from the nearest locant side. Locant means nearest branching side. So you have to write 1, 2, 3. Okay, here also what? 1, 2, 3. So in this case, both the cases what? 3 is a substituent is there. And you have to check the substituents. If more number of alkyl substituents or more number of carbon atoms in that alkyl substituents, then you have to give preference to this one. So 1, 2, 3 is the correct way. And this is not the correct one. Because here it is a methyl group, only one carbon atom. Whereas here it is what? If it is a ethyl group, 2 carbon atoms. So you have to give preference from this side. So the parent name is 7. So you have to say heptane is a parent name. And these two are, you can say, substituents. 2 different substituents. One is a methyl group, another is a ethyl group. You have to give, arrange the substituent in alphabetical order. So 3 ethyl first, E, and M followed by M. So you have to, this is the correct way of writing the organic compound. So 3 ethyl, 5 methyl, heptane is the correct IUPAC. Whereas in the second case, you can see the second case, there are 3 substituents in that compounds. So this is one substituents, this is another substituents. So which side you have to give the numbering? So nearest locant side. So 1, 2, 3, 4. 4 we are having 2 substituents are there. And arrange substituent, all the 3 substituents in alphabetical order first. So the 4th we are having a ethyl substituent, then you have to say 4 ethyl. And 2 and 4 we are having a 2 times methyl group. So 2, 4. If number and number you have to put a comma. If number and alphabet put hyphen. So 2 times methyl groups, then you have to say dimethyl, and parent name is 6 carbon atoms hexane. This is the correct way of writing the IUPAC. We will see the another one compound which is having a complex substituents. So you have to give them 1, 2, 3, 4, 5, 6, 7, 8, 9. But here 7, 8, 9, 10. So this is the longest carbon chain as a parent name. The remaining things we can call as well substituents. So these are all simple substituents like methyl groups. But in the 6th position we are having a complex substituents. How can you name these organic compounds? So the 10 means is the parent name is decane, and 2 3 we are having a dimethyl, and the 6th position we are having a complex substituents. So further you have to give the numbers as 1, 2, 3. In the 6th position put a hyphen, then 2 we are having a methyl group is there. So 2-methyl propyl, the parent name is propyl. So that should be in a bracket. 6, 2-methyl propyl, decane is the correct IUPAC name. See the another one example. In this case, there are 2 substituents with the same number of carbon atoms. This also 3 carbon atoms, this also 3 carbon atoms. And one more substituent is there. So you start numbering from the nearest locant side. So you got 1, 2, 3, 4, 5, 6 is the parent name. If two same substituents, then you have to use the prefix as bis and mention the position here. 2 we are having a methyl, so 2 methyl. Third positions we are having what? This also isopropyl. Instead of isopropyl, you have to say substituent, then you have to say it's bis. And as usual, what? 1, 2. Further, you have to number the carbon atoms. So only we are having a methyl group, then bis. 1-methyl ethyl is a parent name, and hexane is a parent name. That is the maximum number of carbon atoms in a longest carbon chain. That should be the parent name, or you can say root word. Yes. So here some few problems are given for your practice. Write the IUPAC names for the following. So here 3 compounds are given. The 2 in the normal form, 1 in the bond line formula. You have to do the practice. So out of these things, I will work out only one thing. So you have to give numbering from here 1, 2, 3, 4, 5, 6, 7. 7 is the parent name, then you have to say heptane is a suffix, and 2 we are having a methyl group, and 5 we are having, so 2, 5 dimethyl heptane. The remaining 2 you work as a practice, and any difficult please mention in the comment box. Thank you, students.